Welcome back to VirtualLab Fusion's Getting Started tutorials. Today we turn our attention to VirtualLab documents, specifically those which are used to represent light in one form or another. Here we limit our focus strictly to the different types of documents and analysing what information we can extract from them, but we shall in general not delve too deeply into how each type of document is generated. This is closely related to light path diagram and simulation engine considerations, so we direct you to those tutorials for further information on the subject. You can find them linked in the description box below. In this first installment of the document series, we take a look at the three-dimensional ray tracing visualization of the system. This result is obtained by means of the Ray Tracing System Analyzer, an element which is included by default in the LPDs of the Starter Toolbox. In order to generate a 3D ray tracing document, you need an LPD with a system containing at least one active path from a source to a detector through an eventual sequence of components. The Ray Tracing System Analyzer must, as all other analyzers, be selected in the Simulation Engine drop-down menu before running the simulation if it is to generate a result. This type of document constitutes a vital preliminary step in the analysis of a system. A three-dimensional visualization allows a user to check whether the system has been constructed correctly, with all the elements configured and placed according to the relevant specifications. The fact that the visualization encompasses the entire system is also worthy of note. It is then immediate to spot the areas of particular interest, like foci for instance, which can then be studied more in detail through other detectors and more comprehensive simulation engines. For polychromatic sources, a 3D ray distribution can also help shed some light on the dispersion effects. But this document is not only useful internally for the analysis of a system, it can also play a vital role in presenting your research and work to the world. And that is what we shall cover next: how to manipulate the document to obtain a figure that suits your tastes and requirements. Depending on the system and the intended owners of the figure, one perspective or other in the 3D view may be the most advantageous. To adjust this aspect, make sure that the camera mode is set to rotatable, as well as selecting the rotate option in the window menu, and click, hold and drag your mouse until you have reached the desired effect. The scrolling wheel of your mouse controls the zoom. It is possible to work in a similar way with the other available options in the toolbar for the control of a perspective. From left to right, you can zoom directly into a given selected area, control the zoom with a click, hold and drag motion, pan the camera, rotate as we have already seen, and automatically adjust the zoom to fit the whole system in the window. You can always recover the default camera settings with a reset camera option, or select one of the predefined orientations of a rotatable camera in the cube control. It is also possible to eschew the rotation option altogether and fix the view to one of the three coordinate planes, from the front or the back, in total 6 available combinations. All the pan and zoom controls can be employed freely alongside this setting as well. The color, thickness and density of the rays can be adjusted in combination with 3 different brightness options for the background. Other customization options can be accessed in the View ribbon or by right-clicking on the document, and some aspects of the ray tracing engine itself, like the symmetry or otherwise at the source plane of the distribution of rays to be traced, can be manipulated beforehand in the configuration dialog of the Ray Tracing System Analyzer. And as for other documents, the size of a figure can be adjusted manually. Fixing the size in pixels helps to maintain a standard in the image ratio of the figures. The 3D Ray Tracing View document also provides a tab where the dot diagrams for all the relevant planes in the system, source and detectors, and front and back of components are shown in 2D. The particulars of the dot diagram documents will be covered in a separate tutorial. We'll finish this tutorial with a hands-on example of how to obtain a particular configuration for a figure, using some of the controls we have already presented and some additional ones. We invite the user to experiment until they find the settings that work best for them. I'm interested in generating a two-dimensional schematic of the ray tracing in the system where a cross-section along the X-Z plane is illustrated. To that end, the optimum setting of the ray tracing system analyzer is on XY grid with a value of 1 in Y. Now I want a particular image ratio for my figures, so I'm going to fix it from the beginning in pixels. For this particular figure I want the brightest background setting. I also find there to be too many rays. I would like a less cluttered view, so I increase the stride, and for better clarity of the now sparse arrays, also the ray thickness. Because the wavelength is not relevant in this case, and to reinforce the schematic look I seek for this figure in particular, I change the ray color to black. It does not make sense here to make use of the rotatable camera, so I fix it to the plane of interest. All the previous adjustments have somehow hidden the lenses, so I modify the visualization settings from frosted to colored interfaces. If only the rays were of interest, I could also choose to hide the lenses altogether. I make sure that the zoom allows for the whole system to be included, and subsequently I hide the toolbar and the component labels, which detract from the minimalist look of the figure. I make a few more tweaks, like hiding the scale and coordinate systems, and the figure is ready. I can capture it with a copy view to clipboard option with a different external software package for the purpose. To use the same visualization settings in other documents of this kind, it is enough to keep this window open, and with the target one selected, use a copy view settings option. That is all for this tutorial. If you have any questions, don't hesitate to contact us.